Hi everybody, Scott Stanchfield here. I'm just going to show you a real quick example of debugging a deadlock in Android. I've created a little activity here that ends up starting a thread and forcing a deadlock. So I have this start thread function who creates a thread, grabs on to whatever object is passed in as object 1. Note that these are coming in as what's called any in Kotlin. That's basically the equivalent of object in Java. So we're going to grab a lock on the first object, sleep for a little bit, and then try to grab a lock on the second object. Now what ends up happening here is I'm starting two threads pretty quickly right after another, and there's a pause in each thread of half a second before it tries to acquire that second lock. So what ends up happening is the first thread grabs a lock on object 1, starts to pause, the second thread comes in, grabs a lock on object 2, and then once they're done with their little sleep, they try to acquire that lock on the other object. At this point, they can't acquire it, so they lock up. This is a deadlock situation. Let's go ahead and run this just to see what it looks like when we run it. So here's our Hello World button. I'm going to hit him. And if we come back over here and go to logcat, we'll see that they both acquired, but they weren't able to acquire the other one. So I'm going to stop him. If your application locks up like this, what you can do is run in debug mode. So I'm going to go ahead and hit the debugger. And this time I'm going to run it while the debugger's running. And if we take a look at our logcat, we've got our hang. So you might experience this as a hang in the application and be wondering, well, what's going on? Well, what you can do is switch over to the debug tab, and in this first column of little actions, down here I'm hitting this little more. You might see it directly in there depending on your screen resolution. We'll see that we have this little camera here. This little camera takes a snapshot of the thread status of each of the threads that are currently in the VM. So I'm going to go ahead and click on him, and we'll see that several of them turn up in red. The ones that we're interested in here are these thread 4 and thread 5. If we take a look at thread 4, we'll see that his state is blocked, and he's also blocking somebody else. So we can see that he's blocking 11061, which is this other guy. And he's actually locked onto this object. He's waiting for that other thread to release a lock. So he's telling you which thread he's interested in, which thread is actually causing the issue. Now if we named these threads, they would actually show up better inside here. So let's go ahead and do that. I'm going to stop this. And when this thread starts here, I'm going to add in name equals name. So we're saying the name parameter is getting the value name that's coming in from here. And when I run that again, hit my hello world, I've gotten to my lock. Let's go to my debug tab and take a snapshot. And now we'll see over here those little names appear. Now this is really useful if you're starting your own threads to give them a name so that they'll actually show up. And so now we can take a look here and we'll see that he's waiting for T2 at 11061. So the at 11061 is just an object reference ID. It's basically a hash code for the object. And you can actually see a little bit more clearly which guy is waiting for which guy without having to look at the object numbers. So sometimes you're going to have applications where you have contention for common objects or things you want to have going on at the same time. This is one way to try to find out which things are waiting on other things, and from that point on, it's up to you.